I'm June.
And I'm Kathy.
And today we'll be talking about electrostatic force.
When you put two magnets next to each other, they attract and they stick together. And we know that for movement there has to be acceleration, and acceleration means that there's a force applied. But what's the force that's causing these magnets to stick together? It can't be force of gravity because two magnets on a flat table will move together. It can't be force of tension because there's nothing holding the magnets back or together. It can't be force of spring because there's no spring. And it can't be force of friction because the magnets aren't sliding past each other. The force at play here is called the electrostatic force.
When two particles are of the same charge, they repel each other, such as a positive-positive or a negative-negative. However, when they are of opposite charge, they attract.
The electrostatic force can be calculated using Coulomb's law. Coulomb's law states that when there's a particle Q1 and another particle Q2 with distance r between them, the electrostatic force equals a constant K times Q1 times Q2 divided by r squared, where K equals 9 times 10 to the 9th Newton meters squared per Coulomb squared.
Now, if you look at Coulomb's law, you can see the relationship between the electrostatic force and the magnitude of the charge, and the relationship between the electrostatic force and the distance. An increase in separation will cause a greater impact than an increase in one of the charges due to the r being squared.
Now let's look at an example. There's a particle that's charged plus 4 microcoulombs and another particle that's charged negative 4 microcoulombs. The separation between them is 5 millimeters. What's the electrostatic force? We first start off with Coulomb's law. F of Q equals K times Q1 times Q2 divided by r squared.
So if you just plug in all the numbers,
And if you just shove that all into a calculator, you get 5,760 newtons.
when there's 2 or even 3 particles in a straight line, the calculations are pretty simple because the particles can go only left or right. But when you add a third particle at an angle, then it becomes a whole mess.
Whoa there. Let's look at this from a mathematical point of view. Let's say we have 3 particles in an equilateral triangle. Each angle between the particles will form a 60-degree angle. And let's say that we are looking for the forces that are acting on the bottom left particle. There are 2 separate forces acting on this particle. There's a force to the right caused by the negatively charged particle, and there's a force going down and to the left caused by the positively charged particle. I don't really feel like doing math anymore, so let's just label f of e of 1 as A and f of e of 2 as B. F of e of 1 is going in x direction because the particle is directly to the right. F of e of 2 is going into both x and y direction because it is at an angle.
Oh, okay, so basically you just use basic trigonometry. In order to separate fe of 2 into its x and y parts, you put the y into b sine of 60 and x into b cosine of 60. But they'll be negative since they're downwards and to the left.
We can calculate the total y and x forces. The total y is just negative f of e of 2 of y. The total x is f of e of 1 minus f of e of 2 of x, assuming that f of e of 1 is greater than f of e of 2 of x. To calculate the magnitude of this vector, we take the total y forces and square it, and add it to the total x forces and square it, and then take the square root of that total. In order to calculate the direction of the resulting vector, it would be the x component divided by the y component.
Ta-da! You can do Physics now!
See, it's not that hard.
Shut up, June.
Yes, ma'am.